we were discussing last time. So last time we were discussing about limit of which sequence? So what we discussed last time? Limit n tends to infinity 1 plus 1 by n raised to n. Convergent, and limit of this sequence is denoted by this symbol e, right? And e is an irrational number. So e is not a rational number. That can be proved, or if time permits, we'll try to prove that also later on. If you give me a reminder, then we'll discuss that also. Or one can write down the proof and submit it as assignment. He will get marks for that. Right? So is it clear?
Yes, sir.
Okay, now have we proved? Okay, we'll suppose xn is equal to 1 plus 2 upon n. What can you say about this sequence? What can you say about this sequence? So xn is 1 upon n by 2 raised to n, correct? Whatever I have written is correct?
Yes, sir.
Yes, sir.
So 1 plus 1 upon n by 2 raised to n by 2, and I will take its second power. So is it correct?
Yes, sir.
Yes,
Right.
sir.
Now, if I put m is equal to n by 2, m is equal to n by 2, then I will look at sequence yn as 1 plus, then look at the sequence let us not call it as yn. So look at the 1 upon n by 2 raised to n by 2. So what is it? If I substitute m is by n by 2, what is it? 1 plus 1 upon m raised to m. Is it correct?
Yes, sir.
Now, as n tends to infinity, is it equivalent to saying that m tends to infinity?
Yes, sir.
Yes, sir.
Right? And therefore, if I call ym as 1 plus 1 by m raised to m, then what is the limit of as m tends to infinity ym? Is one limit of 1 plus 1 by m raised to m. Correct? But this is same as m tends to infinity means is same as limit as n tends to infinity 1 plus 1 upon n by 2 raised to n by 2, because m is n. And what is this limit?
E raised to n by 2.
E.
E, because this is actually same as limit m tends to infinity 1 plus 1 by m raised to m. Correct?
Sir, but n by 2 is not like compulsorily natural number, no?
N by 2 is not natural number.
But we have proved E for n belongs to natural numbers. So
No. I am letting n tends to infinity. I am not letting. Okay, you are saying here m by 2 is n by 2 is m and m is not natural number. You want to say this?
yes, sir.
Yeah, actually, this sequence is monotonically increasing. So in that case, uh, situation is simple because your n is natural number or not. For example, if you look at function f of x is equal to x, for example, or x square, and for positive x, if you look at this function, what is the graph is like this, right? And if you look at f of n only, look at only at natural numbers. This is a sequence of real numbers. But if you look at function x square, the tendency of function is also increasing. And when I say x tends to infinity, same thing as n tends to infinity. Do you understand the difference?
Yes,
Yes. Right. So limit as x tends to infinity of x square and limit as n tends to infinity of n square. So n tends to infinity n square means I am just taking jumps 1, 2, 3 natural number jumps. I am just taking jumps from 1 to 2, 2 to 3 when I say n tends to infinity of n square. And here what I am saying x tends to infinity of x square, I am continuously moving x towards infinity, not taking jumps. But in any case, the value is going towards infinity. Correct. That is what I want to tell here. When I say m, then as m tends to infinity, then the limit is same because the tendency of this function or sequence is increasing. Correct? Yes.
Yes, sir.
Okay.
yes, sir.
So, but later on we'll technically we'll discuss all these things very more technically. Here I am just assuming something roughly, but limit is that is no doubt. Fine. So, and therefore, what is xn? What is xn? 1 plus 1 upon n by 2 raised to n by 2 raised to 2. And therefore, what is limit of xn?
E square.
E square, right? Therefore, this sequence converges to e raised to 2, e to the power 2. Correct? Now, can we generalize this? Xn is equal to 1 plus k upon n. K is some constant raised to n for some constant k, positive constant basically. Right. Then what is limit of this sequence? Can you generalize this?
To the power k.
E raised to k.
Right. So then limit of xn is e to the power k. Right. And this if you study the compound interest formula, then you will see such kind of thing. Right. Here n is the years, number of years, and if your number of years tends to infinity, the amount tends to growing with exponential rate. Anyway, you just think about it. And whatever problems, whatever examples we are studying in mathematics, right? In 11, 12 standard, you studied some problems. You find limit of this, find limit of that, find derivative of this, find integration of that. Believe that all these problems or these functions or these expressions occur somewhere when solving real life problem. Right? So people trying to solve some real life problems and they formulate the that problem into mathematical model and they try to solve that problem. They came across various functions, various equations. Those equations we are working with, right? That those examples problems we are just looking those problems or examples in calculation point of view at this instant. Therefore, all these sequences or functions where whatever you are using, they are somewhere in real life problem situation that you may not understand clearly at this moment, but that is true. Anyway, look at this sequence. Xn is equal to so what is limit of this sequence? So I will make some adjustments. Right? What additional factor I included here? Now is it equal? Is it balanced now?
Yes, sir.
Because
Yes, sir.
one factor I included in first bracket, and now I am dividing by same factor. So the equation is balanced now. Now can you tell me what is limit of xn? This is actually 1 plus. Right. Now what is limit?
E.
Right. Limit of xn is limit of numerator upon limit of 1 plus 1 upon n plus 1. And what is the numerator? The numerator is just sequence xn is equal to 1 plus 1 by n raised to n. And then what is xn plus 1? 1 plus 1 by n plus 1. Right. So if xn is 1 plus 1 by n raised to n, then xn plus. So, and we know that limit of xn is e. So limit of this, or let us call it as yn. So yn plus. So limit of yn is e. So limit of yn plus 1 is also e. So limit of numerator is e. And what is limit of denominator?
1.
1.
1.
Very good. So therefore limit of this sequence is e. Even though there are some changes, but we can easily understand the limit of the sequence. Right. Now look at some another sequence. Limit of please keep your mic off. Somebody has kept mic on. Okay, what is limit if xn is equal to 1 plus 1 by n raised to 2n? What is limit?
E square.
Square root 2 of E.
Is it correct?
Yes,
Whatever
sir.
I have right. And so what is limit then?
E square.
Right, and this goes to e square because the product of two sequences basically same, that you can easily understand. If xn is equal to 1 minus 1 by n raised to n, so what is the limit of this sequence?
So e raised to minus 1.
Okay, why?
It's in the form of 1 plus k by n, no? Where k is equal to minus 1.
Okay, you can look it in that way, but you can okay, I will try to write down in some different way. Whatever you are saying is correct. 1 upon n minus 1 upon what I want, n upon so how can I write it? Because I want to get in the form 1 plus some 1 by n raised to n. I want to get in this form somehow so that I can guess the limit.
So we can
Right.
add and subtract 1.
Right. So this is simply uh, or denominator. So denominator I can say n minus 1 plus 1 divided by n minus 1 and whole thing raised to n. Correct? You just correct me if I am writing anything wrong. Okay, what is denominator? 1 upon. So denominator is n minus 1 plus 1. Again I will split. So 1 plus 1 upon n minus 1 whole raised to n. Correct? So, well, so what is it then? So 1 as it is upon 1 plus 1 upon n minus 1 raised to m. Is it correct?
Yes, sir.
Yes. Right. Now I will make some modifications because so that I can compare with our original sequence 1 plus 1 by n raised to n. So that what should be here? Right?
Yes, sir.
Okay. So if yn is 1 plus 1 upon n raised to n, then what is yn minus 1? What is the previous to that previous term?
1 by n minus 1 to the power n minus 1.
And what is the limit? Because it's just one step before and one step ahead.
E.
E, right? And therefore, what is limit of xn?
1
Limit.
upon e.
So 1 plus 1 upon n minus 1 raised to n minus 1 into 1 plus. So limit of second bracket 1 plus 1 by n is 1. So it is 1 by e. So in this way, we can have limit of. So you can generalize this, right? You can generalize this idea if I replace 1 by any key, then that could be the generalization, right? So generalization means what? If my sequence xn is 1 minus k upon n to the power n, then what is limit of xn? Fine. So okay, let xn is equal to 1 plus right. So this is my nth term. Then what is x1? x1 is 1. What is x2? 1 plus 1 by 2 factorial, which is 1 plus 1 by 2, which is 3 by 2. Right? What is x3? Right? What is x3? 10 by 6. Is it correct? Yes.
Yes, sir.
Right.
Yes,
So
sir.
in this way, we can calculate successive terms. Now, is this sequence convergent? Is xn monotone sequence? Yes. Is it monotone sequence? Right? Is it monotony increasing? So just compare xn and xn plus 1, right? This is xn. Is the next term xn plus 1. And what is next term? 1 plus 1 by 2 factorial plus 1 by 3 factorial. And what is the last number in this? N plus 1.
By n plus 1.
and second last is 1 by n factorial. Right, and from xn plus 1 it is clear that this first bracket is basically xn plus 1 upon n plus 1 factorial, and therefore xn plus 1 minus xn is basically 1 upon n plus 1 factorial, which is positive quantity. And what does it mean? Xn is less than xn plus 1. Is it true for each n? 1, 2, 3. Right?
Yes, sir.
Therefore, xn is monotonic increasing because terms are increasing. Next term is greater than previous one. Okay, next thing is xn. For convergence, what we expect now?
Bounded above.
So is xn bounded? That we should look for, because if it is bounded above, then only it is convergent. So let us try to think. Before that, note the recall our previous discussion, 1 upon k factorial, or before this 1 upon 3 factorial and 1 upon 2 raised to 2. Which quantity is bigger? See, 1 upon 3 factorial means what? 1 upon 3 into 2 into 1, and I am replacing 3 by 2 and 2 as it is. So which quantity is bigger?
Second quantity.
Second quantity. Same thing, 4 factorial means 4 into 3 into 2, and I am replacing 4 and 3 by 2 and 2. So again quantity is bigger, right? So in general, can I say that 1 upon k factorial is less than 1 upon 2 raised to k minus 1 for k greater equal, you can say less equal than k greater equal to. Right? So is this clear?
Yes, sir.
Therefore look at xn. 1 plus 1 upon 2 factorial plus 1 upon 3 factorial and so on. This is my xn. This is xn. Now I will compare this 1 as it is, 1 by 2 as it is, but I will replace 1 by 3 factorial by 1 by 2 raised to 2. I will replace 1 by 4 factorial by 1 by 2 raised to 3 and so on. I will replace 1 by n factorial by 2 raised to n minus 1. Then this expression is bigger, no doubt, right?
Yes.
Right, so this is true for all n greater equal to. Now, this is geometric sum 1 plus half square half raised to n minus 1, geometric series, geometric sum. What is the sum of this? What is sum?
2.
It is 1 minus, see what is the 1 plus r raised to n? 1 minus r raised to n plus 1 divided by 1 minus r. You know this?
Yes,
Correct?
sir.
And
Yes,
therefore
sir.
what is it? Half raised to n. Here n minus 1. So half raised to r raised to n divided by 1 minus half. Right? Which is 2 times 1 minus half raised to n. Now, so this 2 as it is. Now this bracket 1 minus half raised to n. This bracket is less than 1. Am I right?
Yes, sir.
Yes, sir.
And therefore, if I replace this bracket by 1, then I will get that this quantity is bigger. So what is the conclusion? We started with xn and we found that it is less than or equal to 2, and it is true for every n. Therefore, xn is less than or equal to 2 for all n. Hence, xn is bounded above. Xn is bounded above. Xn is bounded above. Therefore, by which theorem?
Convergence theorem.
Monotone monotone convergence theorem. We have to we have not done the proof, right? We just saw the statement of theorem. Remember, we have to discuss the proof also, right? If I forget, you give me reminder. We have to discuss the proof of this theorem also. Xn is convergent, so this sequence is convergent definitely. Now, what is interesting thing is, if xn is equal to 1 plus, now adding one more, so okay, let us say yn 1 upon 3 factorial and so on 1 by n factorial. What is the difference between previous example xn and this yn? What is the difference?
1 is extra and
Yn is
first.
xn plus 1. Yn is xn plus 1. Where xn is 1 plus 1 by 2 factorial. So remember this. This is the difference. Then limit of yn is same as limit of 1 plus 1 by n raised to n, which is e. This is a very interesting thing. Right. Now is yn convergent? Because xn is convergent, that is clear. From that, can we say that yn is also convergent?
Yes, sir.
Right, because
Yes,
what is the
sir.
limit of yn? Is limit of xn plus 1. Right. And therefore, what is limit of xn? Limit of yn minus 1, which is e minus 1. Because xn is convergent, yn is also convergent, but the interesting thing is limit of yn is same as e. Right. So why that you can think about, or probably later on we'll discuss this because it takes some time. Anyway, this is clear.
Yes, sir.
Okay. Let us see one more example. Let xn is equal to 1 plus 1 by 2 square plus 1 by 3 square plus 1 by n square. Now, do you understand what are the terms? What is the first term of this sequence? This is nth term. This whole expression itself is a nth term. So what is the first term of the sequence? Right?
Yes, sir.
First term is 1. What is second term? Right? 5 by 4. So there is always confusion which is the first term. Most of the time there is a confusion among students. They say that 1 is the first term and 1 by 2 square is the second term and 1 by 3 square is the third term. This is not true. Right? So second term is sum up to 2 numbers. Third term is 1 plus 1 by 2 square plus 1 by 3 square. This is the third term of the sequence, and whatever is this number you can understand. Now what we are interested in, does this sequence converge? Right, so this is our point of interest. Correct. So is it convergent? Is it monotone?
Yes, sir.
It is
Yes,
clear because if you look at xn plus 1, so xn plus 1 is this, and this is basically, if you look at this bracket, this is xn plus 1 upon n plus 1 square. That means xn plus 1 minus xn is 1 upon n plus 1 square, which is positive quantity. That means xn is less than xn plus 1 for all n. Therefore, xn is monotonic increasing. So this is clear. Now, is it bounded above? So question is xn bounded above? And here point is see what the convergence makes sense. What sense? What is the meaning of? What is the significance of convergence? Significance of convergence means what if xn is this 1 plus 1 by 2 square plus 1 by 3 square and so on. And convergence means as n tends to infinity, what happens? That means if you increase n, then we are adding more and more numbers in xn. Right? If you increase n, we are adding more and more numbers. And therefore, as n tends to infinity means we have infinitely many such numbers in this sum. And if sequence is convergent, this sum is finite. Even there are infinitely many numbers in this sum, the sum is finite. That is what the meaning is. Sequence is convergent in this particular case. Is it clear?
Yes, sir.
And therefore, it is very important to know whether it convergent, because numbers are infinitely many numbers as your n increases. What is 100 term? There are 100 numbers. But if you look at 1000 x 1000, then there are 1000 numbers in the summation. Right? If you look at x 5020, 5225, suppose there are 5225 numbers in the sum, right? And as n tends to infinity, you are adding more and more numbers in this, right? So x2 there are only 2 numbers, x3 there are 3 numbers, x4 there are 5 numbers. So in n tends to infinity, you are adding infinitely many numbers. Is it finite? The sum is finite or not? That is a question. That gives very interesting information if you are sure that convergence. Right. So, but monotonic increasing, you have to just check whether it is bounded above. Now, interesting thing is, suppose there are infinitely many people came to a party, right? Therefore, suppose there are infinitely many people came to a party, right? Then, and you want to serve some drink to these people, cold drink or whatever. Infinitely many people came to party, you want to serve some drink. Then, and you have limited stock. You have limited stock of cold drink. Then how will you manage? So what you will do, you will give one glass to first person, 1 by 4th glass to second person, 1 by 9th glass to third person, right? 1 by 16th of a glass to the fourth person. Then what total amount of drink you will need to serve the infinitely many people? Will it be finite? What it will be at most? You understand the problem? You understand what I said?
Yes, sir.
So there are infinitely many people and you want to serve the drink. So you will give 1 glass to first person, 1/4 glass to second person, 1/9 glass to third person, and so on. Continue in this fashion, right? And can you manage all the people in some finite amount of drink? Let us see
Yes.
what happens. So what is upper bound? So what is upper bound of the sequence? At most, how much amount of drink you will need, right? So let us think about upper bound. So xn is 1 plus 1/2 square plus 1/3 square 1/n square. Now this is what 1 plus 2 into 2, 3 into 3, n into n. So what I will do, I will keep 1 as it is, and I will keep these 2 as it is, but I will change, replace 1 2 by 1, right? I will keep 3 as it is, but I will replace 1 3/2, and so on. Continue this. I will keep n as it is and n minus 1 I will replace. So which amount is larger?
Second one.
Second one.
Second amount is certainly larger because the denominator is smaller in each term, right? Therefore, second amount is certainly larger amount. Okay. So note that 1 upon k into k plus 1 is 1 upon k minus 1 upon k plus 1. Is it true? You check this.
Yes.
So this is true for k greater than or equal to 1. This is true. Fine. And therefore 1 as it is in the previous case. Now can I replace 1 upon 1 into 2 by 1/1 minus 1/2? The second term I will replace by this. Correct?
Yes, sir.
Yes.
Third term I can write it as 1/2 minus 1/3. No doubt. 1 upon n minus 1 minus 1 by n. See, I am just using simple properties. Okay, so now this minus half cancels with plus half. Minus 1/3 is again plus 1/3 is present in next bracket. Right, so what is the pattern? The second term in previous bracket cancels with first term in next bracket. This is a pattern now. And therefore, in last bracket, first term of last bracket cancels with second term in the previous second last bracket. But for minus 1 by n, there is no next bracket, so that will survive. So what remains?
2 minus 1 by n.
So what remains? 2 minus 1 by n, and certainly this amount is less than 2.
Yes.
Right, therefore xn, which is 1 plus 1/4 plus 1/9 plus 1 by n square is less than 2. And this is true for all n. That means how many people are in the party doesn't matter, infinitely many. The total amount is less than 2. So how many glass of drink you will need to serve all the people?
2.
At most 2. At most 2, not more than 2 glass. Right. Therefore, xn is bounded above. Hence, by monotone convergence theorem, sequence xn is convergent. Right? So I think we have discussed this in the previous lecture. Discuss or not? Convergence of this. Yes. Did we discuss this?
Yes, sir.
Yes, sir. Yes, sir.
Is it convergent?
No, sir.
I don't remember whether we discuss or not, but I think we discussed somewhere.
Yes, sir. Is
If we go back,
Yes, sir, we discussed this.
yes, we have discussed this. Xn is this, then Xn is monotone, and then we proved that it is not bounded above. What we proved? X2 raised to n greater than 1 plus n by 2. So Xn is unbounded. So tendency of sequence is increasing, but it has no upper bound, so it goes to plus infinity. Right, so it diverges to plus infinity. Yes, we have discussed this. Okay, so then we have proved that limit of xn is infinite. This we already discussed. Anyway, now let us go to the next point. If 0 less than b less than 1, then prove that limit n tends to infinity b raised to n is 0. How will you prove this? How to prove this? There are many other ways. B is basically positive. So what is our claim? What is given? B is between 0 and 1. Right? What is claim? Limit of b raised to n is 0 as n tends to infinity. This is our claim. Means what? If you want to prove that's limit of something, so here what is xn? What is xn is b raised to n. Correct? Now, and our claim is, what is our claim? So limit of xn is 0. That means limit of b raised to n is 0. So this is our claim. So how to prove this now? What is the natural way? What is the natural way? So given epsilon, what we want, given epsilon, when we believe that limit of something is 0 or some number, by definition of limit, when we believe that limit of something, some sequence is some number, so given epsilon, can we produce k? Correct? such that if we can find k for epsilon, then we can believe, right? Am I right?
Yes, sir.
Yes, sir.
So given epsilon, can you produce k? So epsilon is suppose given, want k. So whatever I am writing, it is in my mind. I want to find k now. Right. So how to find k? And what is the value of k? So what is known quantity? What is a known quantity?
Epsilon.
So epsilon is given means epsilon and b are known quantities because b raised to n, b is known and we want to look at limit of b raised to n. Right, so epsilon and b are known. Therefore, our k will be in terms of epsilon and b. Right, so what is known and what is unknown? K is unknown and b and epsilon are known. Right, so what we want, so consider this b raised to n minus 0. We want to make this expression less than epsilon, but it is positive, so no need of this. So observe that b raised to n is less than epsilon if when this would be less than epsilon. We have not made it less than epsilon, but when it will be less than epsilon if how to make it less than epsilon if log of b raised to n less than epsilon log epsilon. Why does it make sense?
Yes, sir.
Why?
So we are taking log both sides.
But if you take log both sides, why inequality remains same?
Because both are greater than 0.
Both are greater than 0, that is fine. But it may happen that if a greater than b, but log of a less than log of b. Right? It may happen that a is greater than b, but log of a less than log b. Why it is inequality remains same? Because b raised to n is greater than 0, epsilon greater than 0, and f of x is equal to log x is an increasing function. Did you study increasing functions?
Yes, sir.
Increasing. Yes, and log x is an increasing function. That is an important property of log x. Means if x1 is less than x2, then log x1 is less than log x2. This is a property of log function. That's why we can apply here. Otherwise, we will not be able to apply that log function. Right? Okay, therefore, that is if n times log b is this less than log epsilon. That is if n log epsilon upon log b. What here now? What inequality? Less than?
Less than.
Why? Then that doesn't make sense. That will not be helpful then if n is less than something. But we want for larger n. We want k such that after that k for all n something is less than epsilon. So n less than something is useless, right? But actually the fact is greater than. Why? See, very simple things you should observe. Where is b? B is less than 1. And there what is log b? Is negative.
Yes, sir.
Log b is negative because b is less than 1. And if you multiply by negative quantity on both sides, inequality reverses.
Yes, sir.
And therefore greater than is correct.
Yes, sir.
Right. And log, if your epsilon is also very small, then log epsilon is also negative. That's fine. But if you divide by log b, certainly inequality reverse. And therefore, can you tell me the value of k? Therefore, if we choose, this allows us to guess the value of k. What should be the value of k? What are the known quantities? Epsilon and b. Now, can you tell me value of k using the known quantities? Yes.
Log of epsilon plus 1 upon b. Log
So
of b.
choose natural number k greater than log epsilon upon log b. Log epsilon upon log b is certainly a real number, right? It may be negative positive. If log epsilon is very big number, suppose epsilon is 150, then log epsilon is positive. Then log b is certainly negative. So this is negative. Then k will be any natural number 1 because k greater than negative number means you can choose 1. But if epsilon is very small, 1 upon 5000, then log epsilon is negative and negative upon negative positive, and that quantity is larger now, right? Log epsilon upon log b. In that case, you have to choose some larger k. It depends on what is your epsilon. But in any case, you can certainly choose natural number k greater than log epsilon upon log b. Then, for n greater equal k, b raised to n minus 0, b raised to n minus, is it less than epsilon? Is it less than epsilon?
Yes, sir.
Because I am choosing n greater equal k, and already k is greater than log epsilon upon log b. That means n is greater than log epsilon upon log b. That means n log b is less than log epsilon. Why? Because log b is negative. And therefore log of b raised to n is less than log of epsilon. Now if I apply exponential on both sides, less than e raised to log epsilon, right? But what is exponential of log? Why less than? If I apply exponential, if x less than y, then e raised to x less than e raised to y. Is it true?
Yes, sir.
Sir.
Because exponential function is also increasing function, right? And so these two cancels, exponential and log cancels with each other. Therefore, b raised to n is less than epsilon. If you choose n greater equal, so can I say directly here? This is less than epsilon. If n is greater equal k, because we have chosen k, so that this is happening. Right, so what is the conclusion?
b raised to
Therefore,
n converges to 0.
right, therefore, for each epsilon, there exists k, we can produce k such that b raised to n minus 0 is less than epsilon for all n greater equal k, and hence limit of b raised to n is 0, provided b is less than 1. So if b is greater than 1, Then what is limit b raised to n?
Infinity or does not exist.
So limit is infinity. Diverges to infinity. That is, if b greater than 1, then the sequence b raised to n diverges to infinity. Right? And how will you prove this? What is the meaning of sequence diverges to plus infinity?
We'll first show it is monotonous increasing and then we'll show it is not bounded.
Bn is monotone increasing, and second point is not bounded above. You need to show these two things, correct? So monotonic increasing is clear, that you can easily show, but not bounded above means what? How will you prove not bounded above? So given any m, no number is a bound, upper bound. So if somebody gives you m, you can produce n such that b raised to n is greater than n. Correct? That means there is no bound m so that all terms are less than m. Right? There is no m such that all terms are less than m. That means if somebody gives you any number m, you can always produce the b raised to n is greater than that. That is a problem. That's why it is not bounded above. That you need to prove. If you want to prove that not bounded above means you need to prove that given any m, I can produce n b raised to n. What is that n? So n depends on what?
B and M.
So b is constant actually, but n depends on m. Suppose somebody gives this number m, then I can produce another n so that b raised to n is greater than m. Therefore, this n depends on m. Somebody gives you some number m, you can give him n. Look at b raised to n greater than. So this happens for every m. So not bounded above. There is no such m at all which is bound. Fine. Now, if b is negative, then what about b raised to n? B is negative, then b raised to n. What happens?
Tends to 0.
Suppose b is equal to 2, then minus 2, then what is b raised to n? What are the terms? Minus 2,
Minus
4,
infinity.
minus 8. Not minus infinity. Terms are on positive side also. What happens? Minus 2, 4, minus 8, then 16, then minus 32. So terms are going negative, positive, negative, positive. So what happens?
It is a divergent, means it does not have any limit.
So if then b raised to n is convergent if 0 minus 1 less than b less than 0, right? If b is in between minus 1 to 0, then certainly convergent, and b raised to n is divergent if b less than or equal to minus 1. Right? So in this case, can we say that b diverges to minus infinity or plus infinity?
No, sir.
No, such sequence is called as oscillating. So Bn is oscillating. It oscillates. It is divergent, but not going towards plus infinity or minus infinity. It just keep on oscillating here and there. Right? So in this problem, first part is easy. Just apply epsilon definition. You can check it easily. And in second case, it oscillates because it is not going towards plus infinity or minus. Okay, so okay, so next time we'll discuss more about sequences. Any doubts?
Sir,